in the GNSS processing pipeline is the step before having a position fix, longitude, latitude, and height.
Welcome to another episode of the Mapscaping Podcast. My name is Daniel and this is a podcast for the mapping community. Today I'm talking to Xavier from a company called Rockobron, and these guys, they're developing the next generation technology for geolocation and navigation. And we talk a little bit about their work, and we talk a lot about the future of smartphones and their role in precise geolocation in the future. Really hope you enjoy the interview. Great to have you on the show today, Xavier. I'm really looking forward to this because you and your company are doing something really interesting with navigation and geolocation. But before we dive into all that interesting stuff, can you tell us a little bit about your background?
Sure. Thank you, Daniel. I'm a research engineer. I've been working on the space business area since the very beginning. I've say roughly more than 10, 12 years of experience now. I used to work on the Earth observation field back in the past, but in the last years, I've been working on satellite navigation solutions. And in this frame, back in 2015, together with my associate, we founded Rockobron, which is a company focusing on satellite navigations, especially those satellite navigations featuring accuracy and affordability at the same time, thus allowing for scalability.
So this is the problem that you're solving, because I'm thinking we have navigation, we have geolocation today, but you're focusing on at an affordable cost. Can you give us an idea, like what is the share of the market that you're aiming for, or what solutions are you inserting your products into in that affordable range?
Sure. Let me explain. GNSS, global navigation satellite industry, has been traditionally divided into two main blocks. On the one hand, we have the mass market side of the spectrum, where product solutions or chipsets are featured by a very low price, very affordable, say tens of dollars or even less, but accuracy, it's rather poor. Okay, we're talking about errors in the order of meters, say 5 to 10 meters. And on the other hand, there's always been the professional side of the spectrum with super good equipment featuring accuracies as good as centimeters, but having a very expensive price, thousands and even tens of thousands of euros. Okay, that was say more or less suitable during the 80s and the 90s, even the beginning of this 21st century. But from the last 5 to 10 years on, there's been a sort of new niche market in the satellite navigation industry popping up, which is featured by requiring accuracies as good as under half meter and requiring as well scalability, which means that its price have to be affordable, and affordable means costing hundreds of euros. And that's basically where Rockobron is concentrating its business.
Okay, so I think you've done a really good job of describing the spectrum there. We've got everything from under centimeter resolution, which is obviously really expensive to achieve that in terms of the equipment you need to buy, and then we go all the way up to 5 to 10 meters kind of thing. And I'm assuming that's kind of the really cheap chipsets. That might be those cheap sort of tracking chipsets that we see around the place. That might be something we have on our cell phone, that kind of thing. And you're aiming for the middle of the market. Like who's using this? Who wants this?
Sure. Technologies such as drones or automated driving or smart logistics, which were technologies not present in our lives 15 years ago, but they are now, and they are going to be, especially for the next 5 to 10 years. Those technologies, they do require super good accuracies as good as tens of centimeters. That's what we call decimetric accuracy. But obviously, they are in need as well of scalability, because you cannot equip a drone with a geolocation solution which is worth thousands of euros. Basically, because the drone itself, even if it belongs to the professional drone industry, it's worth normally 10, 15K. That's why there's this new need in the market for geolocation solutions having decimetric accuracy at a very affordable price.
And I'm thinking also this affordable price, this sort of niche that you're aiming at, you're assuming that we're going to see lots more drones, that we're going to need lots of these things. So we can't buy products that are going to be 10,000 euros just for the geolocation part of it, and buy 7,000 of them, because we need an army, like a network of drones flying around the place. So you're aiming at that side of the market. Is that correct?
Exactly. And I said drones, but we could as well focus on automated driving. I mean, automated cars are going to rely definitely on GNSS geolocation solutions for their autopilots. And that's exactly the same case. You cannot equip a car which is worth 20K euros or 20K dollar with a satellite navigation solution worth 10K. It makes no sense. It's not scalable at all. Therefore, that is the reason why those rather new solutions have been appearing in the last 5 to 10 years, targeting this new niche, which is decimetric accuracy at a price of few hundreds of euros.
Okay, so I think we've done a pretty good job of identifying the business case now, or describing the business case for this. So let's jump into the really interesting stuff for the people that are listening to this. And that would be, in your case, you've got a hardware solution and you've got a software solution. Could you start by giving us a brief description of the hardware solution?
Sure. We're developing and selling a GNSS receiver, a multi-constellation single frequency GNSS receiver, which is called Argonaut. This is a very tiny and lightweight piece of hardware, specially designed to be onboard professional drones. This is a standalone GNSS receiver that basically the main difference is that it does not only provide real-time geolocation information to the drone controller, but as well stores all the GNSS measurements in a memory card for its post-processing. And this post-processing is done with the second half of our solution, which is a service in the cloud, what we call a positioning as a service, named JSON, which is used in order to enhance the geolocation information from standard accuracy. And standard accuracies are, in the case of drones, we're talking about horizontal errors in the order of 2-3 meters, say 2 meters. With JSON, we're able to improve this up to under 50 centimeter.
Now, this is the part of your business that I'm really excited about and think is really interesting, because the idea of having the service in the cloud where I can just upload my data to it, or perhaps even the data is uploaded automatically and processed and delivered back to me, I think is brilliant. And part of the thing that I think is really clever about this is that it's based on a network of public base stations. Is that correct?
Yes, absolutely. Say we're not, to be honest, we're not inventing anything. What we're doing is we're making it easier for the users to have access to precise positioning techniques that have been in the market for the last 10, 15 years, namely RTK and PPP. Those techniques, they do rely on an infrastructure which is used to generate a reference position with which we can do differential positioning and thus achieve very good accuracies. Those references, in the JSON case, could come from a database of more than 10,000 public stations from which we gather information. We keep the database constantly updated, and then depending on where the user has been carrying out its campaign, either a drone flight or a car drive, whatever, JSON is able to automatically fetch this position and then apply RTK to these geolocation measurements in order to give back to the user the enhanced geolocation information.
Okay, so if I could just take a minute here to try and summarize this a little bit for the listeners, because you said a lot there, and I just want to make sure that I understand it as well. So it sounds like this JSON service that you've made is based on this huge network of public base stations. Now, a base station, as I understand it, is a stationary GPS receiver that's there all the time recording positions. So it builds up a whole bunch of positions, and basically it has so you could reference the positions that come from your rover, from your drone, for example, against that, and you could remove a lot of the error. So that means you've got this worldwide network. I could upload any old GPS or GNS data, and if the positioning is close to one of these base stations, I can get it corrected. Is that correct?
That's totally correct. This is what we call CORS, C-O-R-S, which stands for Continuously Operating Reference Station. This CORS GNSS network, as you said, is basically a network of permanent stations. It is basically an existing infrastructure of permanent GNSS receivers spread all over the world, continuously gathering data. And this data, it's publicly accessed. We're relying on this data, exactly as you said, in order to compute differential positioning. And differential positioning is basically stating that if I am close, as a rover, as a user, if I am close to one of these reference stations, I can assume that, 75% of the common errors in GNSS positioning are shared between myself and this station. And this is precisely what allows us to obtain very good accuracy.
So I think we should unpack this a little bit more, because this is not just like this JSON system that you've made, this network that you access, this is not just usable for drone pilots. I think that's important to note. I think that we should say something about that anyone could use this in reality. Like the data doesn't have to come from a drone, does it?
No, absolutely not. JSON works absolutely independently of the use case. I mean, JSON ingests RINEX file. RINEX file, it's the standard in GNSS industry for the measurements file. You can generate a RINEX file from the GNSS receiver on a drone or in a car or from your smartphone, whatever. As long as you are providing JSON with a file with GNSS measurements, JSON's going to get you back the enhanced geolocation information.
Yeah, that's really cool. I love this idea of geolocation as a service. Or what did you call it before?
Well, we call it PaaS, P-A-A-S, Positioning as a Service.
That sounds great. And a really useful tool for anyone else out there that's looking to get a lot more accuracy out of the tools that they're using. Without that expense too, I think this is the thing that I think is cool about it. Without that expense of setting up and running a base station yourself, go out to collect the data, load it up into your platform there, have it processed and get it back again. I think it's brilliant.
Exactly. And in case you're not in one of the coverage areas of our JSON service, because we are totally aware that there are zones in the globe where there are no close reference stations, the service allows you to upload not only the rover data, but as well the base station data, if you have your own base station. Because if you have your own base station, still you require some GNSS expertise in order to post-process, to combine the rover and the base station data to achieve good accuracies. If you don't have this expertise, JSON can do that for you as well.
That is really interesting. I'd like to move on from this now, because I think we've talked a little bit about your hardware solution, we've talked about your software solution, but I'd like to sort of move into more that what this means for the geospatial community. And in the pre-interview, we talked a little bit about the market share in terms of who is accessing or using GNNS data. Can you say a few things about that? How's the market divided today?
According to European Satellite Navigation Agency, which is the European public entity responsible for the Galileo constellation, they do a periodical market report about GNSS, and they are basically stating that almost 94% of the total GNSS yearly business comes from only two market segments: automotive, that accounts for 50% of the market, and smartphones, that account for another 44%. Therefore, those are clearly the two market segments where to focus in order to be successful in this business.
Yeah, okay. So roughly 43% of all GNS use is coming from smartphones, roughly.
Roughly, yeah. In summary, that means that traditional GNSS, the idea we have about GNSS, which is surveying, cadastral activities, very, say, scientific-like activities, that represents only a 6% of the overall market. It is amazing. I mean, most of the business in GNSS is coming from mass market segments.
I think this is really interesting because in terms of geospatial, in terms of location, it really shows the penetration into the market, into our everyday lives. I mean, location is just baked into everything we do. And we can see it, I think, here in terms of the smartphone industry and their use of it. So that's really interesting for me. But the other thing that we mentioned, or we talked a little bit about in the pre-interview, was the changes that we've seen in the smartphone market as well. Can you say a few things about that? There have been a couple of big changes in the last couple of years. What were those?
Back in 2016, Google or Android presented the new version of Android software for smartphones. I think it was Nougat version and onwards, in which they allowed developers to have access to GNSS measurements. GNSS measurements in the GNSS processing pipeline is the step before having a position fix, longitude, latitude, and height. So the previous step is having access to GNSS measurements, which are basically pseudo ranges, carrier phases, Dopplers. Those GNSS measurements are the basic materials you need to carry out precise positioning. So basically, back in 2016, Android opened the door to have precise positioning in your smartphone. That was the first important event. The second event was last year, almost 1 year now, when the Chinese smartphone manufacturer Xiaomi announced that its flagship smartphone, I think it was Mi 8, was featured by a dual frequency GNSS chipset. And that was for the very first time a smartphone having dual frequency GNSS chipset. For those not familiar with this, having dual frequency GNSS chipset allows very powerful precise positioning techniques. So the combination of these two news, it is basically stating that the smartphone market segment is strongly betting for precise positioning.
I think that paints a very, very clear picture. So what we've got is we've got a huge market share taken up by smartphones, and we've got these two pieces of news that sort of show where we're heading, that precise positioning is something important and it is a real focus of the people that are developing these products. But I guess the thing that'd be really interesting for the listeners of this podcast would be, what are the use cases of this? Okay, great. So we're going to have way more accurate location from our smartphones, but what are we going to do with it?
Yeah, sure. Say, imagine that all of a sudden your smartphone can be used as a precision geolocation tool. Okay, that would allow us that will trigger a myriad of applications now we cannot even think about, such as blind people guidance. If you have a smartphone providing you a geolocation error under 1 meter, we can think about guiding impaired people walking around the streets of our cities. Or we can as well think about using the smartphone as the precise navigation tool in our automated driving car. Or we can transform our smartphone into a GIS surveying tool. That would be some examples.
I think this is really interesting for the geospatial community, because we're seeing more and more people sort of outsourcing this collection of geospatial data, for example, and the smartphone is a fantastic tool for that. And so there's a lot of people working with computer vision, for example, and to create and generate and update map data, which is fantastic. But they're at the moment, I guess they're limited to that location that comes out of the smartphone. But what we're saying here is that in the future, that location will be so much more accurate, and that'll be a huge benefit to that industry, I could imagine. And I guess what we're really talking about in the grand scheme of things is democratizing precise geolocation.
But that's the basic idea. The concept is exactly this one. I mean, since every one of us has in its pocket a smartphone, from the moment on we will have precise geolocation on our smartphones. Precise geolocation is going to be accessible for everyone. I mean, a technology that used to be for a minority affording equipment worth 10, 15K euros 10 years ago, it's going to be now in our hands in a device that we already have. So it's going to be for free, or almost for free, because normally that's going to rely on a correction service that you will have to subscribe to. We already have the hardware platform in our pockets.
I think this will be a giant step forward for the Internet of Things, and for when you think about drones and what they might mean in terms of data collection or delivering packages or surveying or whatever. This will be a giant step forward for the industry if we can produce these low-cost geolocation engines, which is basically what our cell phone is becoming, and we already know how to produce them, and we already know how to produce them at scale. So if we can take that engine and start inserting it into robots, inserting it into other sensors that we're going to use with our Internet of Things, that this is a huge leap forward, or will be.
Sure. And not only this, but the smartphone's use case, it's amazing because it opens a new wall of possibilities by the fact that there's millions of smartphones. We can think about collaborative positioning techniques. We can think about collaboratively generating geolocation data information in a massively manner that can generate new business opportunities, applications, solutions, whatever. And that is the reason why Google or Android is putting the focus in it. And smartphone manufacturers are starting to provide as well dual frequency GNSS smartphones.
That's a really interesting thought, that what you said just before in terms of a collaborative network. So basically we could have every cell phone in the world that was collecting high accuracy, high precision geolocation. We could have it contributing to a network, and we could solve that proof of location problem. For example, we could have cell phones confirming the location of other cell phones, and we would have a terrestrial navigation or positioning network. And and then we could compare against GPS. We wouldn't be solely reliant on that one source of geolocation.
Precisely. That's exactly what you said. I mean, the more geolocation sources of information you have, the better your geolocation can be estimated. And yeah, I mean, collaborative geolocation, it's not new. Smartphones will open the door to optimally exploit those collaborative positioning techniques. And not only positioning techniques, we could as well estimate ionospheric weather, which is something very important for weather forecast. Using collaboratively dual frequency GNSS measurements from the network of smartphones, we could think of the best weather prediction tool ever.
I think I've heard this statistic thrown around quite recently in the news and in the media, and that is that 80% of all data has a location value attached to it. or is somehow relative to a location on the Earth. And if we think about that in terms of that data, we're going to have the ability to precisely position that. I think that's gonna throw a lot of use cases out there, and that's going to be a really interesting time. Hey, I can see that we're slowly but surely running out of time. But before I let you go, I've just got a couple more questions, and one of them would be: we've talked a lot about the future and where we're going with this. What's the thing that you're most excited about when you think about this kind of technology, this kind of application, and maybe also in terms of your work with Rocketbrunn?
Well, in Rocketbrunn, we saw from the very beginning that smartphones were the future of satellite geolocation. Basically, because it's the only way to have a totally democratized, precise geolocation access. From the very beginning, we've been involved in that. Proof of that is that we are in a pretty important European Age 2020 project named Flamingo, which is striving to provide a service, a correction service, tailored especially for smartphones, to have this precise geolocation in smartphones. So it has to be said as well that the technology is not yet fully deployed. It's not yet there, right? I mean, smartphones allowing this are only the flagship smartphones, high-end smartphones. So we will still have to wait, say, another 5 years in order to have this technology widely present in our pockets, in our smartphones, and then probably in parallel, projects such as Flamingo and other similar initiatives will have been working to be ready to provide the ancillary services that are needed to have precise positioning in your smartphone.
What you said there just before about positioning as a service, you talked about that again, and providing this sort of post-processing of this location data. Could you imagine a time in the near future where we won't need to post-process GNS data?
Sure. I mean, post-processing is what we're doing today at Rocketbrunn, because there's a set of applications that they do not require real-time precise positioning, okay? And our Argonaut plus JSON solution is targeting those post-processing precision applications. However, most of the near future applications, they do require real-time precision, such as drone flying or automated car driving or impaired people guidance. They do require real-time precision. So those correction services that are already popping up will serve this purpose. So the future, it's definitely real-time.
Xavier, I want to thank you so much for taking the time to talk to me today. It's been an absolute pleasure. I've learned a lot. I'm sure our listeners have learned a lot. But before I let you go, can you tell us where can we go to learn more about you and your work?
Yeah, pleasure was mine, Daniel. And yeah, please visit our website, www.rocketbrunn.cat, if you want to have more information about Rocketbrunn and what we do.
Thanks again, Xavier. Really enjoyed it.
Bye-bye. Thanks to you.
And that's it for another episode of the Mapscaping Podcast. My name is Daniel, and I just want to say thanks for tuning in again this week. It's much appreciated. I had a little bit of trouble with the audio on this one, so just in case you missed it, Xavier's company is called Rocketbrunn, and you can find a link to that in the show notes at mapscaping.com. You're also more than welcome to reach out to me on social media. That's Mapscaping at Facebook and Instagram and Twitter. I'd love to hear from you. See you next week. Bye.